Hey, good afternoon, everyone. I thought what I'll do is do a quick video, sort of going over the assignment. I mean, the spec is already fairly detailed, but I thought just walking you through some of the important aspects might be helpful. Okay, so what are we going to do? We are going to write up a instant messaging application. I'm sure all of you use one or many instant messaging applications, be it WhatsApp, Telegram, Signal, Facebook Messenger, you name it, right? So the goal here is to just give you an appreciation of designing such a application. Now, of course, by no means are we designing something that is that you're going to actually deploy in the commercial space. But what you'll be designing is a simplified version of it, but still there's a fair bit of functionality that you do need to implement. Okay, so what exactly are we doing? Well, yeah, of course, the spec has all the information, so make sure you read it. And we kind of recommend you read it a few times. And please also make sure you keep checking the latest version on the assignment page, because invariably with such a large spec, there could be some typos, some things that perhaps are contradicting. And as some of you may point them out, I will go in and fix some of those errors, right? So just make sure you're keeping an eye on the latest version, right? If there are any major changes, I'll announce them, but I don't expect any significant changes beyond just some minor edits to fix sort of inconsistencies and typos and stuff like that. Now, of course, all details are in the spec. So things like the deadline, what sort of file names, the way to submit, the precise marking guideline. We've even given you some example interactions at the end. So certainly read all that up there. I'm not going to go over each and every bit of that here. I'll just focus on the key functions. And then now, of course, you're welcome to either choose C, Java, and Python. Just make sure you know what version is supported on the VLabs, because that is where we will be testing your program. Right, so you have to essentially write two main components. So you have a server. The server is always on. Now, your server doesn't need to remember state from prior execution. So the way we'll test it is basically we start your server, then we initiate a few clients, we go through the various steps of interactions, and at the end we close everything, right? So we're not going to keep restarting your server and stuff like that, unless of course it crashes, then we might have to restart. But the normal testing behavior does not require us, your server, to sort of remember state across executions. When the server starts up, you may assume there are no clients online, of course, and then the clients will initiate the connections with the server. So the server is responsible for a number of things. It needs to first authenticate the user. And then once the user has logged on, the user would interact with the server through certain commands. These include allowing the users to send messages to each other, be the other endpoint be online or offline, or even broadcast messages. Then check the presence of other users. So that's what we call a presence notification. A user might want to blacklist or block another user. And the server should also keep track of the activity of users. So if the server observes that the user is not issuing any valid commands for a certain period of time, they would assume the user is inactive and log that user off. Next, the server should also enable a second mode of communication, which is called P2P messaging. So the two clients should be able to send messages to each other directly bypassing the server, right? So if you think about it, your server is essentially going to implement what's called a request response interface, right? For the clients, it's always going to be the client sending some request, the server doing some processing, and then the server initiating a response. Sometimes, of course, the server might be the one. So for example, if one client is sending a message to another client, then the server has to sort of send that message to the other client, right? So just be mindful of that. But essentially, it's you are designing the way for the client and server to interact with each other, right? The client will interact with the user through the command line. So that's fairly straightforward. The user, as in the person who's using your client, will type in certain commands. So when we are marking, it's basically going to be your tutor. Your assignment will be manually marked by an actual person. There is no auto marking involved. So your tutor would be typing in these commands basically. And then of course the client has to initiate interactions with the server. Now everything must happen over TCP. As you may expect, this is a messaging application. So the requirement is that all messages are reliably delivered. And the best way really is to rely on TCP to do that. Otherwise, you would need to implement that in your application, and that will make it even more complex, right? So really what you're going to do is implement your own application layer protocol. I mean, we've told you what exactly the client and server need to do, but the precise messages that are exchanged between the client and the server and the exact way you implement things is entirely up to you, right? So your application protocol has to decide how the messages would actually look like, that the client sends to the server sends to the client, the semantics of the various fields, and even the sort of what happens when a particular message is received, right? Of course, we've given you the spec, but you actually need to implement that. So all of that is encompassed within what's referred to as the application layer protocol. And you have seen some examples of this, right? You've seen HTTP, you've seen SMTP, you briefly saw BitTorrent and stuff like that. So that gives you some examples. You don't necessarily need to follow those protocols, but you can use them as examples. Right, so the execution is fairly straightforward. All programs will be run on the same machine. So the clients and the servers will be executing on the same machine. You may assume the IP address of the other endpoint is just localhost. Now that one. The server will be executed first, and the server is provided with 2 arguments. So the first argument is the port number that the server is going to be listening on, basically, and waiting for the clients to connect. So this can be any port number greater than that and less than that. The second argument is the duration for which a user will be blocked if they keep entering wrong passwords. So this is called the block duration. The third argument is the timeout. So this is the duration of inactivity after which a user is logged off. The client just takes one argument, which is the port number that the server is listening to, right? So this allows the client to know where to send with which endpoint it should set up the TCP connection, right? So it would be, the IP address would be that, and the port number would be that. The client side port number, you don't have to specify, just let the operating system pick it for you, okay? And the client would then initiate this connection. And once the connection is established, your user is considered logged on, assuming the authentication is successful, of course, right? So that's the absolute first step you must do. Once the TCP connection is established, the client should prompt the user for a particular username, and you can assume that the server would have access to a file which contains the usernames and passwords. The format is all specified. You may assume that the file contains usernames and passwords in the correct format. There are no errors and stuff like that, right? And you can assume this file has read and write permissions, and it is in the current working directory of the server, right? So we have given you an example. Now, mind you, in our tests, we will use a different example. So do not hard code anything, but we can certainly use that for your tests. Now, the process of login is fairly straightforward. Ask the user for the username, then that username gets sent. Now, remember, the redemption file is at the server. It's not at the client. So the client has to tell the server, hey, this is the username that wants to log in. The server needs to check if that is a valid username. If it's an invalid, by valid we mean if the username actually exists. If so, the server then probably sends some sort of message to the client. Again, that interaction is for you to decide. Then the client prompts the user to enter the password. The password is relayed back to the server. The server checks the password. If it matches, if it doesn't match, it asks the user, sort of conveys that message back to the client. The client would ask the user to enter another password. Now, if the user keeps entering incorrect passwords 3 times, then they are assumed to be blocked for a certain duration, which means from that point on, for a certain block duration, that same user is not allowed to log in. If the username doesn't exist, then it is assumed that this is a new user, and then the server would indicate that to the client. The client would prompt the user to enter a new password, and then a new account gets created. And at that point, the user is considered to be logged in, right? Now, again, mind you, you can assume the username and password being entered is in the correct format. So you don't need to do all those sort of checks, okay? So that saves you a lot of work essentially for checking for errors and stuff. Now, the instant the user is logged in, the server should inform all other users that this particular user has logged in, unless there are users who may have blocked that particular. No, it should be the other way, right? Unless, so if I log in and if I've blocked some other user B, that other user B should not see the fact that I've logged in, right? I think I'll fix that up in the slide here. I didn't mean it this way. Maybe I'll do it live right now, so you can also see that. So when a user logs on, display a message to all online users. Who this user may have logged. Okay. Right. So if I'm user A, I'm logging in and I've already blocked some other user, they should not be able to see that I've logged in. So this would happen in a case where you're probably already logged on once and told the server that you're logging in a particular user, and then you disconnect and you log back in after some time. So at that point, this would make sense, because if you're logging in for the first time, there is no way you would have blocked another user, right? Okay, so detection of inactivity. So this is something the server needs to do. So the server needs to keep track of, and again, by server here, we mean there has to be some communication between the client and the server for the server to be aware that this user is inactive. So again, that's part of your protocol, how you do it. But the two endpoints somehow need to keep checking that the user who's logged in is actually issuing some valid commands, which could either be for clients in the client server mode or in the P2P mode. But if no valid command is issued for the timeout duration, then the user is assumed to be inactive and then logged off. Yeah. The next thing is the messaging itself. So this, the first bit here should allow a user to send a message to another user. So they would say message that particular user and the actual message. And again, here you may assume that the format of the message is correct. You don't need to do any checks. If the user is online and has not blocked, then of course, this particular sender, you would send the message. If the user is offline as has not blocked that particular sender, you store the message. If the user, if the recipient here was had blocked this sender, then you would report an error, or if the user doesn't exist, then you would also report an error. Right? A broadcast message gets sent to everyone who's online. So you don't. So remember again here, if the message is in offline mode, you will have to store the message, right? With broadcast messages, you only deliver messages to all online users. So everyone gets the message unless, of course, the sender had been blocked by someone else. And remember, blocking is one way. So maybe I'll talk about that here. So who else, right? So these two commands allow a user to detect the online status of other users, excluding, of course, those who have blocked the particular user that's actually running this command, right? So who else tells you who all are currently online, and who else since tells you who all had logged in that particular time since behind, essentially. So let's say you have been running the server for 2 minutes, and you say who else 60. So it will tell you for the past 60 seconds who have all been logged in, right? Of course, if time is greater than the duration for which the server was running, you basically assume from the start time of the server, because you can't go back in time, right? Okay, blocking. So this is blacklisting. So essentially this allows a user to block someone. So if user A has blocked user B, that would mean B should not be able to send any messages to A. Okay. B should also not be able to receive a presence notification about A. B should not be able to check the online status for A, right? And remember, this is just one way. So if B has locked A cannot do all this, but B can still send a message to A. B can still see the presence of A, and so on and so forth, right? So the relationship is only one way. Just remember that. Unblocking does exactly the reverse, right? So it sort of reverses that, right? Now remember, when you're blocking, this information about which users one particular user has blocked will have to be maintained by the server, right? And a user could block multiple users. So that list is sort of dynamic in a sense. Then finally, of course, a user should be allowed to log out, and this information should be conveyed to all eligible users. If there is a P2P messaging session also active for this particular user, then you should tell the other user you have been chatting to directly that this particular user is logging off, right? Error handling can be fairly simple. So we'll do this in a very minimal manner. So what we'll do is we might try to check if some of these commands may work with invalid users. We might try an invalid command, and that's really about it. So you don't have to do exhaustive error checking. As I already indicated, you may assume the formatting of the message is correct. This time is in the correct format, and so on and so forth. I mean, this will be an integer, for example, right? So you can assume that it's an integer. We're not going to be extremely picky about all those error conditions. We are mainly interested in the correct execution of the program. Okay, so the first bit is the client server mode, which we've been looking at. Now, your server should obviously support multiple clients. Otherwise, it wouldn't make sense to just have one client do running a messaging app. So what that means is your server should be able to set up multiple TCP connections with multiple clients and interact with all of them, right? So you can imagine your server process initially binds to a port, and then it listens to that particular port. So this would be the port specified at the command line of the server. The client would start up, it would initiate the connection. Now, once the server returns from this, essentially, when it sets up this connection socket, we recommend you use multi-threading and initiate a new thread here at the server, and then basically fork a thread, and then let this thread be responsible for communicating with this particular client. And then your main thread can go back and keep listening for new connections. Then if another client comes in, initiates the connection, you can spawn off another thread. And once this returns, you can basically have the second thread talk to this particular client. So effectively, your server creates as many threads as it needs, as the clients that it's communicating with, right? And then, of course, once the client logs out, that thread can be killed, right? Your main thread should keep running forever, right? The assumption is the server just keeps running, remember? So you don't have to worry about that part. The P2Me messaging allows two clients to talk to each other directly. However, to set that up, you still need to go through the server. So one of the users would initiate, say, a start private command. Then the server would first check with B that, hey, are you okay for, first it would check if that user has blocked, right? So if user B has blocked user A shouldn't be allowed to chat with B. Then, of course, assuming there is no blocking, then the server would check with user B if they're willing. And again, here, when I'm saying this verbally, what that entails is you'll need to send some messages between this server and the client. Then the client would have to sort of display something to the actual user and say, hey, this person is trying to set up a P2P connection, and are you okay? And then ask for yes or no. The user would enter either yes or no, and then you would act on that, right? So assuming B agrees, then remember you would need to then set up a TCP connection, right? So here we have, say, A talking to the server, sending a start private message. The server checks with the client, assuming the client is okay. At this point, you would need to now set up a TCP connection between these two directly, right? Now, exactly how, there are various ways you could do this, but somehow for example, this client would need some information about this client in order for it to set up the TCP connection, right? So that's something you think about and figure out how to convey that information. You'll have to use the server to convey that information to one endpoint, and then this endpoint can set up the TCP connection. And at that point, you could essentially have something like that, right? So at this point, each client now has two TCP connections, one with the server and the other one with the other client, right? And so for all the private messaging, the messages have to be sent over this connection, right? For all the client server interactions, you would be sending messages over that connection, right? So all of this, this can basically happen concurrently, right? Yeah, and then once the connection is set up, the user can initiate private messages directly between themselves without having to go through the server. And once one of the user wants to conclude, they could stop the private session and the other endpoint could be told, right? Now we'll simplify things a little bit in that we'll assume when we're testing that each user will only be involved in one P2P session at any given time, right? So you don't have to worry about necessarily each user managing multiple chats, right? It is certainly possible for the user to move back and forth. So in this scenario, user might sometimes send some commands to the server, sometimes send some commands to the for P2P chat, right? So there should be flexibility for the user to do both. And remember, the client also needs to interact with the user through the command line, right? So effectively, your client has to manage some input from the actual user, right, through the command line. The client also has to manage interaction with the server, and the client also has to manage interaction with another client, potentially, if there's a P2P connection. So effectively, your client has to kind of do three things in in parallel. So again, for your client also, you might want to consider multi-threading. That will allow you to manage this much more easily. Alternately, you could look at non-blocking IO. So essentially using select, where you're sort of not, because remember here, you can't just, for example, you can't just let your program wait for the user to type something. If your program is waiting for the user to type something and the server sends, say, a message, let's say another user has messaged this user, then your program is not going to receive that message and display it to the user, right? So you can't just sort of remain blocked and waiting for the user to actually type something. So that's one way to avoid that, is essentially to use multi-threading. Another way is to sort of cycle through all your all of these three things essentially. So that could be done using select. So you could explore either option. Since you're going to use threading at the server, you might as well, if it's not too difficult, you might as well just adopt the same concepts for your client as well, right? Okay, so that's, and of course, there will be another video where Wei Song will go over some of the coding aspects of multi-threading. So certainly watch that video. I'm just giving you a high-level overview. The other video will go into a lot more detail about multi-threading itself. And we've also given you some sample code. I'll point you to that. Basically, it's on the assignment page. The other thing you also need to be mindful of is the data structures, right? So your server actually needs to manage a lot of state if you think about it. Your server needs to remember who are the valid users, how many of them are online, when they logged on, who have they blocked. The server might need to store offline messages. The server has to keep track of activity. So there's a lot of state, right, that the server has to maintain. So please be careful about what data structures you're going to use, and please be careful about how these data structures are accessed across multiple threads, because otherwise you'll run into all sorts of weird issues. So really spend some time thinking of these data structures. And one recommendation I would make is avoid some arbitrary limits, right? So you don't know, for example, how many users there would be, right? You can read the credential files and that tells you how many users there are at the start, but we may create additional users, right, in our tests. So please do not assume any upper limits. A good idea is to just use dynamic memory allocation for defining all the variables. People get scared about that, but that is the correct way to do it, right? Because assuming any upper limits is like hard coding stuff, and generally hard coding anything in your code is not a good idea, right? So how do you start? I mean, there are a lot of things you need to do. So certainly it might seem daunting at the start, but again, like any complex assignment, you do it step by step. So first of all, start with a simple server, a simple client. Make sure your client can actually interact with the command line. The user can type something, the client can read that, the client can send that to the server, let the server send back a response. So do that basic setup, right, between a client, a server, and say the client accessing the terminal. Next thing you might want to do is do the authentication part. This you could do even with one client to begin with. Now, once that is done, you will fairly early need to move on to multiple clients, right? Because that is the essence of a messaging app. It's no good to have a messaging app that can just support one client. So you would then extend your server to support multiple clients. You could start off by doing basic presence notification. So once a user logs in successfully, inform the other users. Then move on to messaging, initially just one-on-one broadcast, then add offline, which requires the server to remember stuff. Then move on to perhaps detecting inactivity. So allow the client and server to somehow come up with a way to keep track of if the user is entering valid commands. If not, they need to be logged off. Then add support for the who else and who else since commands. Then do the blocking. And once all this is done, tested, then move on to P2P messaging, right? So that way you're sort of building slowly and adding new functionality, right? And again, remember, if you go through the spec, you'll see that there are marks allocated for each of these, right? So again, we of course encourage you to complete the whole assignment, but for whatever reason, if you're unable to do, say, P2P messaging, you're still going to achieve, say, I believe almost 70% of the assignment is dedicated for the basic client server setup, right? So yeah, that way you're doing things modularly in a modular manner. Now, in terms of what is actually displayed to the user at the client side, just any text is fine. Just make sure it's meaningful. We gave you some samples, but you don't need to match them. The assignment will be marked manually, right, by actual person. So it's not like we're checking against some auto-generated code, auto-generated messages, right? You don't need any messages at the server, so it's only the client. If you do want to add some extra debugging messages, you're welcome to do that, but then just add an extra flag, optional flag, as indicated in the spec, which will allow you to enable the debugging mode if you really want it for your own sort of sanity. For the report, it's just a very short summary of your design, the program design, the data structure, the application layer protocol, any trade-offs. And if at all your program is not working, make it clear there so the tutor can read it and know that, okay, this functionality was not implemented, for example. And also please cite any borrowed code, right, that you may have used. Okay, so testing is rather important. Make sure you test your programs. Make sure you're testing it in VLab. This is extremely important. We do appreciate you may not want to use VLab for doing the actual building your assignment. You may use an IDE on your own machine, perfectly fine, right? Certainly do it. But remember, we cannot test your code on your machine. We can only test it in VLab. So if your code doesn't work in VLab, what are we supposed to do, right? So we can't give you any marks because we cannot test your code. So please make sure you're porting everything, doing all thorough testing in VLab, and making sure that it's working through command line, because we are not again going to use an IDE in VLab. We are going to run programs through the command line, right? And remember, there can be some peculiar differences between operating systems. So VLab uses Linux. If you start coding on your, I don't know, Windows or Mac machine, you may find some peculiar differences, and we can't really help you with that, right? Because these are very specific to your machine and there are so many different flavors. So how do we manage that? So really the onus is on you to keep every major code update you're doing, keep checking it on VLab, right? So all testing really must be done on VLab. Another thing I forgot, which I should perhaps add here, is I'll add it in capitals. Please resort to systematic debugging, right? I mean, currently we are seeing messages on the forum where people say, okay, I'm writing a web server, it doesn't work. What do I do? Now, how are we going to know what exactly happened, right? There could be various reasons why your server might not be running. So it's not very helpful to just post messages like that. We would strongly encourage you to use a systematic debugger. There are debuggers available in your IDE. If you prefer, you can of course use JDB. What's the one for Python? I forget. Or GDB for C. So the equivalent version for Python, right? The command line debugger. It allows you to set checkpoints. It allows you to step through your code. It allows you to see the values of various variables. So please follow systematic debugging. Please add printf statements as you need to check status of various things in your code. So that is really the only way you can find bugs, right? Because it's a complex piece of code. You must follow systematic debugging procedures. You must follow unit testing. So for each function you're developing, make sure it's working correctly. So these are standard programming practices, right? Remember, this is not a programming course, we assume you're able to do, you have taken a systematic programming course before. So this is sort of standard programming stuff. We are not asking you to do something different here in that regard. The other point is plagiarism. So this happens every term. Every term I warn students, and every term, again, it's a minority, but there will always be a small group of people I end up having to go and chat to, and invariably I have to give them a 0 because they clearly plagiarized from other students, right? So we do run your programs to plagiarism detection software. So please do not do it. You're just cheating yourselves, right? And both parties involved are considered guilty, even if you may not have plagiarized, but if you have given your code to someone, you're equally guilty, right? So we can't accept those arguments. We cannot accept arguments where you say, oh, I put my code on GitHub and I forgot to make it private. No, that's your fault, right? You put it up there for people to go and access, so you are culpable. So if you are putting up things on GitHub, which we understand you might want to do, just make sure you disable access, right? How difficult is that to do? It's just one simple setting that you need to set, right? So just be very mindful of this. This is something I hate doing. And every time, despite saying this, either in a physical lab, a physical class, or in a virtual class, I end up catching a small minority of students doing that. Next, non-CSE students. So again, this is in the spec. So these are basically students who are not enrolled in a CSE program. They can opt for the non-CSE version, but they must request permission. So if you do fall in this category, again, check the spec if you are eligible, and then email us, and then we will tell you whether or not we grant your request. Do not assume that you are eligible for this. The default assumption is you are not eligible, so you must seek permission. Now, in terms of resources, there's a fair bit of resources on the website. Particularly the web server you have done in your lab 3 will be useful for you here. There is actually a lot of code. So in fact, if you go to this link, this particular link here, you'll see there's a lot of code available and a lot of resources, right? So make sure you look at this page and look through the resources. Make sure you look through the clients, the multi-threading resources, that we've provided. And also make sure you look through the video, that the second part of the video that Wei Song has done, and which should drop together with this video, which goes over multi-threading in more detail. In terms of help, of course, you can keep posting questions on Ed, and we'll answer them as soon as we can. We are also going to organize consults for the assignments. This will follow the midterm. We don't want to do it now because we want to also let you focus on the midterm for the next couple of weeks. So the schedule for this will be announced maybe week 6 or so, and there will be separate consults for C, Java, and Python, and you can go there and seek help from the tutors. Now, again, mind you, don't send your code to the tutors and ask them to debug. That is not what this is meant for, right? You must be able to debug your code. The tutors will guide you. They will give you some hints. If you have specific questions, they'll answer it, but they're not going to debug your code for you. Okay. And very often your answer will be in the spec. So certainly, I mean, I'm happy to refer you to the spec, but it saves you time, really, if you just make sure the answer is not already in the spec, right? Yeah, so that's all I have in this video. So hopefully you found it interesting. And as I noted, do check out the second video that will follow on multi-threading. So yeah, have fun with the assignment. Hope it doesn't seem too daunting. In the end, I hope you enjoy it because it gives you, I mean, in the end, you're going to implement something which is what you use on a daily basis. Now, mind you, it may not be as sophisticated as some of the apps you use, but at least it gives you a flavor, right, for what is actually happening under the hood. So hope you enjoy that, and I'll see you in the lectures next week. Bye-bye.